Howdy, my name is Kyle Willis, and today I'm going to be presenting my entomology final project. For this project, I wanted to take a look into how pesticides affect honeybees, more specifically the Apis mellifera. And so after doing some research, I narrowed down this topic and I wanted to take a look into the effects of imidacloprid on the gut microbiome of the bees, and I wanted to see if that led to an increase in mortality rate. So I had assumptions going into this a project about how it would affect the bees, but after doing my research, I was pretty shocked to see how it actually affects them. So I'm excited to share my findings with you today. To start, I'm going to be discussing some background information of the bee that I'm studying, which is the Apis mellifera. And I also want to talk about the fertilizer imidacloprid and provide some background information on what the gut microbiome is. That way we get a full picture of everything before taking a look into my research question. So my first slide, I want to talk about the importance and just some general information about the Apis mellifera. Um, so the Apis mellifera were imported to the United States from Europe in the 17th century. The biggest factor that these bees play is their role in pollination. They pollinate a wide variety of plants, including many crops that humans rely on for food. These bees are estimated to pollinate 1/3 of all the food crops around the world, and they're also the primary species of bee in honey production. They're used for other things, other than pollination and honey production. We use, some of the products that they produce in cosmetic items and even pharmaceutical drugs. So my next slide is over imidacloprid. I wanted to provide some background information on the fertilizer that I chose to use. So imidacloprid is a fertilizer, a pesticide that's used around the world. The goal of this pesticide is to protect farmers' crops against pests. Imidacloprid, it can spread through the plants and eventually is consumed by the bees when they're harvesting the plant's pollen and nectar. And the National Pesticide Information said that this, imidacloprid is not toxic to birds or fish, but it's very toxic to honeybees and other insects, which is why I chose to take a look at this. And it's a very popular um, pesticide. In 2015 and 2016 alone, there's approximately 1 million pounds used in the United States alone for agricultural purposes. And it's mainly used on cotton, vegetables, and fruits. So next, I wanted to talk about the gut microbiome. The gut microbiome, plays an essential part in maintaining the overall health of bees. Some of the main functions are listed on the slide, but the microbiome helps break down food, and there's gut bacteria that's also present that helps detox certain chemicals. And the microbiome can offer protection against other pathogens and helps bees regulate their immune system. So overall, the microbiome plays a huge role in maintaining the bee's health. And that's why I wanted to see if imidacloprid had an effect on this system. So now that we have some background information, I wanted to see if exposure of imidacloprid affects the gut microbiome, and does that effect lead to an increase in mortality rate? So despite concerns about what imidacloprid exposure does on the gut microbiome, studies showed that imidacloprid does not change the composition or diversity of the gut microbiome in adult honeybees. Um, so this really just shows the resilience of the gut microbiome. Um, the microbiome stability helps, when bees come in contact with chemicals, other systems that are less stable are more likely to be affected. Um, and so this chart here to the left from the American Society for Microbiology shows that that imidacloprid does not impact the gut of the bees. Uh, and both panels show consistent patterns across days for both the control group and the imidacloprid group. So this shows there's no significant, shift in, the overall health and stability of the microbiome. And so here's another chart on the gut microbiome. Um, this is from the American Society of Microbiology, and this just further shows that there's no change in the bacterial abundance found in the bees' microbiome. So this just further supports the point that imidacloprid does not significantly affect the microbiome of the honeybees. So next I wanted to see if it did lead to an increase in mortality rate. So um, imidacloprid has been found to temporarily impair the bees. So this makes it much more difficult for the bees to make it back to the hive after consuming imidacloprid. So when bees are out trying to find, get back to the hive after, hunting or gathering pollen, um, it makes it harder for them to get back. So they have an increased risk and attacks from predators, as well as prolonged exposure to the elements. Um, and the chart provided from the Library of Medicine shows the survival rates of honeybees that return to the hive after 3 days of exposure. The graph on the left shows that survival rate is significantly lower when bees are exposed to imidacloprid when compared to the control group. Um, this also leads to a reduction in foraging activity. So it alters their foraging behavior. They spend more time foraging for food and less time bringing it back. And so this puts a major stress on the entire colony that they're not coming back. So, in conclusion, when I began research on this topic, I assumed that imidacloprid would be toxic to the bees and that would be the cause of the death. And after research, I found that this is not the fact. When bees consume imidacloprid, it temporarily impairs the bees. It has no effect on the gut microbiome because the gut bacteria found in honeybees are resilient to imidacloprid. Um, and bees are also able to eliminate the fertilizer from the body rapidly. But imidacloprid does impair the bees, which makes it much harder for them to get back to the hive and increases their chance of mortality due to exposure in natural conditions and predators. So, as a significant slide, um, if we don't make a change, we could see a major impact into our world as we know it. As stated earlier, honeybees are crucial to our everyday lives. They pollinate a third of the crops we eat across the world, and long-term impacts would be, a decrease in honeybee populations, but as mortality rates increase, and the human lives would be impacted as well, as our health and nutrition would be impacted, as a reduction in pollination would lead to a reduction in crops that we're able to eat. How can we fix this problem? This is a slide I wanted to include. We could reduce the use of pesticides unless it's absolutely necessary for the health of crops. We could utilize low impact pesticides that break down rapidly after use. That way, the pesticides do not spread to the pollen and protects the honeybees. And we could restrict usage periods where we could use the chemicals during times when bees are not as active. And here's my reference slide. So I appreciate you tuning in, and I hope you have a good summer.